Good morning, everybody. Thanks for being here. There are a few of you here, so I appreciate that. Probably I'll say this a bunch of times this semester, but it is a little bit easier to do with some people out there in the world. Hello, good morning, Captain Price. Hey, Killer Pear, Glazer, good morning. Hopefully everyone had an okay first week. I don't know if any of you has done all online classes before. I certainly have not, but hopefully you find your rhythm for it sooner than later. Morning, Atsuya, how are you? Okay, so we are starting week 2. The video froze already. Has it for me? Hopefully it's just on your end. I see what you're talking about. Yeah, give it a refresh. And we haven't covered anything yet, so it'll be okay. Okay, that's good. Okay, so I'll just give you a heads up about what's going on in the class overall, and then we'll go in and do some content. So this is week 2. If you look, I posted an announcement, and the announcement is I dropped the team project because I was just looking at the amount of work that I'm already asking you to do. Yes, indeed. I just thought it was not going to be any valuable learning experience that I could think to make of it anyway. So I decided it was just busy work, and I got rid of it. So there's no team project. Everything else stays the same. So you'll do some homework questions every week. You'll do a programming activity every week. We'll have a discussion prompt every week. And then there are 2 projects, long-term projects. And you've all had a programming class, so your 2 projects are basically the same as you would see in any programming class. And in this course, because the projects are slightly less important, we have less of them. That's all. Hold on, sip. And I know the discussions are probably going to feel like a pain in the rear sometimes, but it is a way to sort of keep everyone sort of engaged in a place where we can potentially have discussions while we're not meeting face to face. And I also, for me personally, I just kind of need the same routine every week. If we were to have discussions like every other week or every third week, I would struggle with that personally. So some weeks I'll give us a break and I'll just put a poll out there or something, so it's not nearly as much of a burden. But it is an effort to try to give us some space where we can have some question and answer when we're not physically in the same space. Anyway, so that's that. So this week we've got 2 things. Let me open up. The other thing about the class. So I have now created 5 weeks worth of content, and my goal this week is to just see how far I can get. So I will do my best to stay at least 2 weeks ahead of you constantly, and eventually that means I will have the whole semester's content posted. If I have a really good afternoon today, I'm hoping maybe I can actually this afternoon and this evening and after dinner maybe get 3 weeks worth of content up. But there are 5 weeks, and there will be more content being posted, so that eventually. Oh, I forgot to update this and take the team project off. Let me kill it real quick. So you've seen, you will witness the death of the team project. Okay, so now it's fully gone. Okay, anyway, so that's what's going on in the class. No team project. I've got 5 weeks worth of content, and I will continue uploading content until I got the whole semester out there. Yes, you can. So Grossifag asked, should you post here? Yeah. So while we're doing the live broadcast, you are more than welcome to ask questions in the chat. And usually, and in fact, almost always, if you have a question, other people have that same question, so I can answer it, and it will be there for other people to hear the answer for later. So yes, please have at it. Okay, so we are in week 2. So I'm going to go look at the week 2 module, also just as a reminder for what you're going to see. The goals for the week. So the first set of goals have to do with representing information with different numbering systems. You all should know the decimal numbering system. That's the base 10 numbering system that you do your math classes in, and that you no doubt have spent your whole life counting in the base 10 system. But in computer science and in computing broadly, we also need to have a sense of how the binary and hexadecimal numbering systems work. So we're going to get started on how do we understanding the different numbering systems that are commonly used in computer science, and then convert information between the different numbering systems as a way of getting some comfort level or fluency with them. And then the other thing we'll do is some more HLA programming. We're not doing any sort of assembly style HLA programming yet. We're just getting used to the HLA language. And once you're used to the HLA language, then we can start adding in or mixing in some assembly style programming. So I will talk about that when I give you some tips about working through this week's programming assignment. The HLA language and what it can and can't do. So that's the goals. Data representation in binary, decimal, and hexadecimal numbering systems, and then some basic approaches to HLA programming. You're going to recognize everything. It's just going to be structured a little bit different in the HLA language than whatever you're used to using. The readings. So what you're going to see, by the way, is that often you're going to have the same, I'm going to refer you to the same chapter multiple times. So for my money, if you read through these chapters fully the first time you encounter a chapter in the book, the next time I refer to that chapter, you'll probably have a better sense of where specifically in the chapter you might look for specific answers for my money. But anyway, so there's two chapters. These both link out to PDFs in the book. And then I wrote the homework questions, and I designed the programming challenge based on what you see in those readings. Yeah, so Captain Price says it helps. So no doubt Captain Price read the whole thing, and I think you'll find that it will help. And eventually you'll probably be able to be a little more selective about how deep to go in the reading. But while you're getting used to this new programming language for you, it can definitely help. It's got coding examples, and it's got complete programs as examples, and there's other stuff in there. Like I'll do every week in this class, after class, I will take my Twitch video and I will push it over to YouTube. And then I download it from YouTube, and then I upload it to a captioning service so that we have ADA compliant captioning on the video, and then I'll put all the links and embed the videos after all that gets done. But that'll always be on Monday afternoon. So if you look back later today, the video of what I'm doing right now will be here to watch later. Oh, that's sweet. I didn't know you could do that. Captain Price says you can actually use the narrator software in Windows since it's a PDF. I'm glad you said that, Captain Price, because if someone asks me, I can say, oh, and it'll sound like I knew that myself. I guess now I do, so thank you. Okay, so the homework. I don't typically go through the homework just a whole lot, unless there's questions about it. This is really just to review key concepts from the reading. Pardon me. But a lot of the homework questions this week are about translating information between different numbering systems, and I'm going to hand work some problems for that right now, in fact. So let me switch my display. So you're about to see how I do virtual whiteboard. Yeah, and the quizzes will always be on time because they're not really there to get you or call you out. They're there just to call your attention to what I consider to be the most significant things. All right, so let me switch to my camera. So I know it's a little bit dark in there. It's the best I can do in this light, so I will try my best to write big enough that you can see. But anyway, instead of using a digital whiteboard, which I just think takes longer for me, I'm actually just going to write on paper. So we're going to talk about binary. Let me see where I can go. Actually, I can go all the way to the bottom, and then I can go I can go all the way to the top. Okay. So we're going to talk about binary. Numbers and decimal numbers. I hate this pen. And hexadecimal numbers. So this is kind of the textbook part of this week's class. You are going to see binary, decimal, and hexadecimal in your HLA code eventually, but for now, the goal is to understand the difference between these numbering systems and how they work. So we'll start with decimal because that's the one that you're accustomed to. And I just want you to notice that there's... I actually have... now I work on a Linux machine, so Surfaces are out because it's using Microsoft is against my programmer religion. But I did buy a tablet, and I didn't think it did. It didn't make it any better, so I just stuck with the paper. And I also just honestly, I kind of like feels more like me to do it this way, sort of old schoolish. Okay, so decimal, you know this, but I want you to notice there's some patterns here. So another word for the decimal numbering system is the base 10 numbering system. And this is this is a system that we use to represent value, information, like the number 99, which is a decimal number, although it could be a hexadecimal number. It's just a way of representing some value or some quantity, right? So base 10, and then here's sort of the patterns. So it's base 10. You use 10 symbols. To represent base 10 values. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those 10 symbols, or what we call digits, of course, are the legal ways of representing a base 10 or a decimal value. But notice base 10, 10 symbols, base 10, 10 symbols. And then we also, in base 10, use the powers of 10 to represent information. So decimal, which really just means 10, right? A 10 system. Base 10, 10 symbols, powers of 10. That's correct. So binary is a base 2 system, which we'll go over here in just a second. But that's correct. Binary is a base 2 system with 2 symbols and powers of 2. Okay, so what do we mean by powers of 10? If I write down a value, I'll use 99. What that value means actually is in the first column, the rightmost column, what we mean is there are 9 of some power of 10 in that column, and the first column is the 0 column. So what we mean when we write down 99 is, in part, we have 9 10 to the zeros. Now 10 raised to the power of 0 is just 1, so that's 9 times 1, which is the quantity 9 in decimal. But when you start to move up columns, you get larger powers of 10. So that next column over is 9 of 10 to the first. And if you do the math, 9 times 10 to the first is 90, plus 9 times 10 to the 0th is 9, which brings you back to the original 99. So what we mean by powers of 10 is as you move up in value from right to left, add more columns, you are adding larger powers of 10 to the value. Yeah, and there are other ways to sort of work this problem in your head, which is why our discussion prompt asked you to go out and see how other people present it. But this is the way that I learned to make sense of these numbering systems. So the value 99, when we say 99, what we're kind of saying is 9 10 to the firsts plus 9 10 to the zeroths, which in base 10 arithmetic is 90 plus 9 or 99. Now, before we look at the other two, I'll just point out to you the reason why we are often going to talk in terms of decimal values is because that's the one that we're most familiar with and comfortable with. So we will always use decimal to sort of come back to our comfort zone. So if we're talking about binary numbers, we'll often say, well, it looks funny in binary. What would it look like in decimal, so that we can at least make some sense of the quantity of it. Okay, so let me push this over and do binary. Binary by base 2. So this is a base 2 numbering system. It's represented by 2 symbols. Captain Price already said this in the chat, zeros and ones. Does anyone know where that comes from, by the way? Why binary when we are working inside of computers? There's something special about binary that makes this useful for storing information on a computer. That's right. So for all intents and it's if you're an engineer, you're going to object to what I'm about to say, but for the purpose of computer science, zeros and ones are really just how we represent information in a computer, because they're electronic, and an electronic system can either be on or it can be off. So we use circuits and different combinations of ons, ones, and off, zeros, to represent information. So why we're doing this in a computer science class is because binary ultimately is how we store information in an electric or an electronic computer. Yeah, that's right, killer pair, transistors. So it's a base 2 system. We represent it in zeros and ones, and why it's important to us is because this is how we actually end up storing information way down deep inside the computer. And you can probably guess what the powers of is, because there's a pattern here. Yeah. If you think about how big the streams of zeros and ones are, I mean, literally like trillions of zeros and ones are flowing through my computer right now. It's boggles the mind how fast these machines are. So binary, base 2, 2 symbols, powers of 2. Okay, so when we say the symbols, we mean that those are the only options you have for representing data in binary. We're very used to decimal and having the full range of 0 to 9 options, but in binary you've only got these 2 options, which means you will never see a binary number with a 2 in it or with a 9 in it, because those are not legal characters, symbols for representing binary values. Convert to words. So when we say that we convert binary to like a character, that's really just a trick of the computer monitor. So we create a circuit that sees a particular combination of zeros and ones and is told to print characters based on that combination. We do it with colors and everything else. It's pretty amazing, really. Okay, so base 2, 2 symbols, powers of 2. So you're going to end up with values that look like this. Right? We know that that's a legal binary value because it uses only the symbols that are binary. Now it also could be a decimal because these are legal symbols for decimal. In our class, because the HLA language does it, when we are talking about binary numbers, we're going to use the percent sign in front of it, which will tell us, each other, and our HLA code, we're talking about a binary number here. So you see that percent sign and all ones and zeros? That's a binary number. That is a base 2 number that is built around powers of 2. In our class, If you see a value with no symbol in front of it, that's a decimal value. Okay, so 21. So let's do the breakdown. So powers of 2. So what we're saying here then, if we start at the far right column, that is the 2 to the 0 column. And we have 1, 2 to the 0. 1. So this next column is the 2 to the first. They just count up. So this next column is the 2 to the first, but we have 0 of those. The next column would be the 2 squared column. And we have 1 of those. And the last column is the 2 cubed column, and we have 1 of those. So it takes a little bit of getting used to, but you can represent any of the same information in binary that you can in decimal. The sort of main rule of thumb is that it takes a lot more zeros and ones to represent a piece of information than the decimal system, which allows us to represent larger quantities with fewer symbols. Yeah, so it goes 1, 2, 4, 8, 16. It doubles every time. This is what Captain Price is saying. I've been watching League of Legends, by the way. I want to say Captain Flowers. Sorry. I just about said it. Okay, so we'll do the math on it. So one way that, while we're practicing, to confirm that we're correct is we'll do math on this and convert it back to base 10 to see what sort of it means, what the quantity is. So 2 to the 0 is 1. So 1, 2 to the 1 is 1. The next column is no 2 to the first, so that's 0 times 2, which is 0. If we go to the next column, so that's 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, so 1 times 4 is 4. And then the next column is the 2 cubed column, and 1 times 2 cubed, which is 8, is 8. So our final value as a decimal number is 13. And I'm going to write it, notice, without the percent sign because I've sort of converted it to decimal. Also, I know it can't be binary because it has a 3 in there. 12 and 1 should be 13. Yeah, it's 13. But you guys should check because we all make those mistakes. It's definitely 13. Okay, so there's a binary number. It's a base 2 number. Uses 0 or 1. That's it. 2 symbols, base 2, powers of 2. And then I did a little bit of decimal math on it. So I took the binary number and I did a conversion back to decimal. Mostly because that's the numbering system that I understand the best, because that's the one I work with almost exclusively in my life, like all of you do. So that was just what would it look like in decimal. So that binary number, if we represent it in decimal, would be 13. Okay, so let's do hexadecimal. These are base 16 numbers. Okay, base 16. So you already know this part. The number of symbols to represent base 16 is 16. So there's 10 of them, and then the last ones we get by using letters. So in the hexadecimal or base 16 system, there are actually 16 symbols that we use to represent information. 0 through 9, but then to get to up to 16, we actually add A, B, C, D, E, and F. We don't have a base 12 system, but you can actually have any system that you want. Occasionally, you'll encounter octal in computing. That's a base 8 system. And there was a base 12 computer in like the 40s or the 50s, but I can't remember who made that computer. Like Digital Equipment Corporation, maybe, I think, might have made a base 12 based computer. But I never see it anywhere. Okay, base 16. 16 symbols, powers of 16. Now this is usually where just trying to get it to do a little bit of focusing. It's a little fuzzy, sorry about that. I'll experiment with the software that I'm running. It also might be a dirty lens, but probably it's just needs to be focused a little bit better. Hopefully I'm writing big enough where at least you can match what I'm writing to the words that I'm saying. Okay, so base 16. Now I'm going to flip the page here in a second, but just to briefly introduce you to the base 16 or hexadecimal system. Base 16, 16 symbols, powers of 16. In HLA, to differentiate hexadecimal from decimal and binary, we use the dollar sign. So when you write a hexadecimal value in this class, use a dollar sign, which makes it so that we can tell the difference between decimal, which has no symbol, and binary, which uses the percent sign. You will also use these symbols inside of your HLA code when you want to write a hexadecimal or a binary, or you want to write a decimal value. Okay, so let's do one. Oh, and by the way, I forgot to tell you this. So what we say is 0 of them, 1 of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them, 8 of them, 9 of them, 10 of them. So A kind of translates into 10 of something, 11, 12, 13, 14, 15. So I'm going to do an easy one so that the math stays easy. But here's 1F. I know that's a hexadecimal number because it has a dollar sign in front of it. It cannot be a decimal because it uses the character F, which is not legal in the base 10 system. And I know it can't be binary because it has an F and it has a dollar sign. And neither of those things is associated with binary. Okay, so now let's translate it. We'll do some decimal math on it just to see kind of what it means in decimal. So we have F, which is 9, 10, 11, 12, 13, 14. That's 15 of the first column of powers of 16, which is 16 to the 0. So notice the first column, 2 to the 0 for binary, 10 to the 0 for decimal, 16 to the 0, base 16 for hex. And then the second column would be 1 of 16 to the first. And if we added another character, that'd be 16 squared, 16 cubed. Those get really big really, really fast, right? Okay, so let's do the math. 16 to the 0, thankfully any number raised to the power of 0 is 1. So 15 times 1 is 15. And 16 to the first is 16. There's one of those, which is 16, which gives us 31. And again, I translated it to decimal just to understand what it is. 31. Okay, so good question. Where did I get the 15 from? So in hexadecimal, when you see an F in a column, that means, in terms of decimal arithmetic, that means 15 of that quantity. So F means that there are 15 16 to the zeroths. And then the 1 means 1 of 16 to the first. Hey, it finally did a little bit of focusing. Okay, so I'm going to do a couple more, and then I'm going to switch over to the programming part. But let's do a couple more. Let me flip my page over. And then I'll share with you the secret of binary and hexadecimal. So I'm going to write down a number. Let's write down something simple like 10. Now, potentially right now, this is not simple because the symbols are valid for binary, decimal, and hexadecimal. All three of those systems use those symbols. So in our class, you're going to have to stop and ask yourself, is that binary, decimal, or hexadecimal? In this case, you know that it's decimal because I did not use a symbol in front of it, a percent or a dollar sign. So this is decimal. Plus, I just told you it's decimal. So I'm going to translate this into the other two systems to see how that works, to see what it would look like in the other two systems. So this is 0 of 10 to the 0, the 0 of the first column. It is 1 of 10 to the firsts, right? Which takes us back to the original 10 in decimal. So let's do binary. And I'll show you the way that I typically do it. There are other ways to do this. So the problem in binary is I'm trying to figure out what would decimal 10 look like in binary. So here's how I work the problem. I kind of start out with just a blank. 2 squared, 2 cubed. So I start with a blank that I'm going to fill in. I know that binary, there's going to have a column for 2 to the 0, 2 to the first, 2 squared, and 2 cubed. So what I need to figure out is how much of each of these quantities do I need to make 10? Now the trick from going to decimal to binary is that you write down your little template here, and then you work from left to right. So you sort of have to work backwards a little bit. So I just start asking myself, I'm going to write my 10 down here. If I have a decimal 10, how many 2 cubes are there? Now in binary, all you really have to answer is there a 2 cubed in there? Is 2 cubed 8? Does 8 fit? It does. So I write down a 1 in that column. And then I take that quantity out. So I have a 2 cubed, which is 8. So I'm going to take it out and see what's left. And now I just keep working my way down. So the next column is 2 squared. And I ask myself, how many 2 squareds fit in 2? In other words, how many times will 4 fit into 2? This is a 4-bit binary. That's true, killer pair. The term for 4 bits, by the way, is a nibble. Okay, so I had 1 2 cubed, so I took it out. 2 squared, there are none of those. It's actually too big to fit. So there are no 2 squared in there. 2 to the first, which is 2. Are there 2 in there? There is, in fact, a 2. And I'll take it out. And then I have to fill in the 2 to the 0, but there's nothing left, so I just write a 0. So hopefully everyone gets that what I have here is 10 in decimal looks like this in binary. Pretty easy. Hex is the easiest one of all. Because hex, all I have to do is take those 4 bits, figure out what those 4 bits are in decimal, and write down the hexadecimal character for that thing that has a dollar sign. So hexadecimal, I don't actually have to do any math other than to take that quantity in binary and figure out what it is in decimal, but I already know it's 10. And then I figure out what symbol in hexadecimal means 10. Which is A. So that 1010 in binary looks like 10 in decimal, looks like A in hexadecimal. Good one. Yeah, so Gersovac got it. It's an A. So does everyone, hopefully you get, this is all the, pardon me, this is all the same quantity. So what we think of as 10 in decimal, like, can I get both my hands in there? Both my 10. By the way, base 10. 10 in decimal is 1010 binary and is A in hex. All right, I have 4 minutes to do a harder one. So let's do the 21. Which is a little bit harder. Oh, that's funny. Yeah, that's true. 10 out of 10, which is an A. Okay, so 21 in decimal. Now we know that because I didn't use a symbol in front of it. It can't be binary because it has a 2. Could be hex, but since there's no dollar sign, we know it's decimal. So let's do binary. This one's harder as it turns out. Because this one won't fit in the first 4. So we're going to add a little bit to our conversion algorithm. Okay, so when you're doing binary, you should always work in 4s. So if you have to go further than 4, add 4 more. And then add 4 more, and then add 4 more, and you'll see the magic of this in here in just a second. Pardon me. So, and then this will be 2 squared. I didn't write down the first 2 squared, 2 cubed. I didn't write down the ones in between just because that's getting a little bit messy. Yeah, so the question, how would we know how many places it'll take in binary? So let's add that little trick. So if you write down powers of 2, let's go all the way up to 2 to the 7th. You'll notice a pattern here. So 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. I'm cheating now because they just double. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. So I wrote down 8 of them. And the reason is because if I can't fit my value in the first 4, then I'm going to have to add an additional 4 to make it work. So what I do with my decimal value is I find the largest thing in here that fits without going over. So I want to do 21 in binary, and I noticed that I'm pretty sure that's going to be right, Captain Price. So I want to do 21 in binary. So I'm going to go down here until I find the first one that would fit without going over, which is 2 to the 4th, which is 16. So I'm going to go ahead and add 2 to the 4th. This one would be 2 to the 7th. So we're going to, remember, always add 4 more. It's going to seem weird at first until I show you the hexadecimal part, and then it's like magic if you like this kind of thing. Okay, so I know I have 1 2 to the 4th in here that will fit. And I can start sort of reducing my value by that 16. I had to go 4 more because the magic won't work if I don't, but I only needed this one, and these are all too big, so they just get zeros in them. Those don't fit. But I need all 4 of them for the next part to work. Okay, so 2 to the 16, that leaves me with 5. So now I have to work my way down, back down to 0 until this becomes 0. So 2 cubed is 8. that don't fit. 2 squared is 4. That does fit. 2 to the first is 2. That's too big. 2 to the 0 is 1. That's a yes. So I went as far as I needed to go to the left, and then I worked my way back down to 0. So this is what this binary looks like, and Captain Price is what you wrote, right? Yeah. Okay, so now here's the magic. When you go to do hexadecimal, you go back to the binary and you take 4 at a time. I forgot to put the percent sign in front of it. You take 4 at a time. And you take those 4 and you make those decimal and then turn that into hexadecimal. So this in decimal, these 4 by themselves would be 1 times 2 to the 0 if we pretended like this didn't exist. So this in decimal is 1. This in decimal is 4 plus 1 is 5. And I'm done. It's hexadecimal. So the reason why you have to do 4 at a time is because then the little magic trick of turning binary into hexadecimal works easiest. So I took those 4 and pretended like they were by themselves, and they become 1. And I took those 4 and pretended like they were by themselves. They become 5, and like that I have my hexadecimal value. Pretty neat. And that's it. That is 21 in decimal. If you want to confirm it, you can do the math. That's 1 times 16 to the first, 5 times 16 to the 0, which is 16, plus 5, which is 21, which is where we started. Pretty cool. That's the whole reason for hexadecimal, by the way. The reason why we use hexadecimal a lot is because it's basically just shorthand for binary. The conversion between hexadecimal and binary is so simple, and hexadecimal is always smaller, that we often use hexadecimal in our programming basically as a replacement or a shorthand for binary. Pretty neat. So that really is, at the end of the day, still binary in a sense. So pretty neat. Okay, so we're going to come back to this again next week and practice it some more. You're also going to see it in code. But if you get to the discussion prompt, some of you have already been in there for this week and made some really good contributions for websites and videos. I saw some links in there. So there are other ways to understand how these numbering systems work, and mine just happens to be my way. So if you find somebody that explains it better for you, that's great, and please share it with us if you do. Okay, so I'm going to close out this section and then go look at code for a bit. So why decimal? Because that's what we've all been trained in all of our lives. Why binary? Because that's what the computer needs to store information. So to really understand what's going on in the computer, you need to sort of understand how the binary system works. Why hexadecimal? Because that is shorthand for binary, and like any good engineer, you should like to spend your time on new problems, not old problems. So if you can do something more efficiently, like write a value down in hex instead of binary, then you're going to opt to do that because it's a more efficient way to spend your time. Yes, most of the time, if you look at actual machine code, it's going to be presented to you in hexadecimal. That's true. That's true. Okay, so let me turn that off. Oh, there we go. Okay, so I can disabled. So switching gears, I'm going to get us started in the lab. Actually, let's look at the browser first. I'm going to get us started in the lab. Remember, the discussion boards are there for you guys to discuss things. So if you have a question, don't feel like you're cheating to put a question in Piazza, and don't feel like you're helping someone cheat if you give them the answer. That's what we hope to do with it. So if you have lingering questions, or you encounter a way or know of a way to explain it differently that might help someone, please share that. Okay. So we're going to switch gears, and I'm going to get you started on the code part. Most of this coding assignment is just to show you what does a loop look like in HLA, what does an if statement look like in HLA, how do you make a variable in HLA. It's going to be very familiar to you with the little differences, and I'll point out to you the things that bother most people about HLA, myself included. But I will say that I like the HLA language a lot. I think it's fun to program in. Okay, so here's our assignment, and I'm going to go through it as I would if I were one of you, and then I'll sort of stop and leave some goodies behind. Use your input, repeat until. Okay, so what do we need? We need two variables and a character variable, a greeting, a forever loop, a loop to make sure they only enter 1 through 50. And then, okay, so I can remember, or at least I can remember to be close to all that stuff. Okay. CentOS. So I've already launched my virtual machine, and I was just going to start on this spot. No, that's not what I want to see. I want to see this. Okay. To remind you about how to log in, so the password is password, PASSWORD, and then you press enter to log in. And then your desktop should be pretty much the same as my own. You're going to have a folder that I put there for you. I recommend that you save all your files in there so that you just sort of get the routine down faster. The other things to know before I start doing the code, if you want to shut down your virtual machine, you could go down here to what looks like more or less the Windows Start button. There is a leave option, and there is a shutdown in here. Or you can log out, but typically I work, I finish, and then I shut down. I think most of you have figured this out because everyone... props to you all, by the way, because everyone turned in a programming assignment in the first week. So thank you for that. It's always feels good, believe it or not, to know that everyone figured out how to do it, and hopefully that means that you felt good about it too. The other way you can get out of here, though, is you can click the X at the top. I'm going to do this, and hopefully it doesn't shut me down. What should happen, you'll get a little dialog, and you can just select the power off the machine option, and that should be fine. Okay, but I'm not going to do that. I'm going to do some programming instead. So here's how I would go about this work. Just like in the first week, I would open up this folder. I would, from inside this folder, go to the tool menu and open up a terminal. The reason you want to do this is because then the compiling stage is simpler because you're already inside the folder you need to be in. So now I have my terminal so that when I've written some code, it will be easy to compile it. The other thing you want to do is fire up the text editor. I'm going to move this up and make my screen a little bit longer. Okay. Mine opened up, it says untitled document, so the first thing I'm going to do is I'm going to save the document. So I'm going to click save. Now here's the part where you want to be careful. Don't just click save quickly. Pay attention to what you're doing. So what we want to do is name the file something with .hla as an extension. I'm going to call it lab2.hla. The other thing to note here is that I didn't put a space between lab and 2, and Don't put a space in there. That's not good. No space. If you don't like them smushed together, put an underscore. But people have had problems with putting the space in there in the past, so don't do it. Either smush lab2 together .hla or lab underscore 2.hla. Something like that. I just smush it together because I think I can read that just fine. So that's step one. Make sure that you get a good name on it. In this case, it's lab2.hla. The second thing is to make sure that you save it inside of the assembly folder. So that's on the desktop, the assembly folder. That's the place with the starter. So I'll just make sure that my new program goes there. I just accidentally changed the name. We don't use Replit in here, so Replit is not going to help you in assembly. Now I clicked on starter. So you can write it in VS Code. It's not going to help you because you don't have a compiler for HLA for that. Now if you're talking about a different class, that's a different question. Let me make sure that this is lab2. So assembly people, be careful. Lab2.hla or whatever the project or lab is, no spaces, and make sure it goes in this folder. If it doesn't go in this folder, you're going to have complications and you're going to have to move the file around later. So just make sure that before you click finally save that the name is correct, the location is correct, and then you can click save. You can confirm that, by the way, by going back to this folder view, and you will see, there it is, in there. Okay. There's a question about VS Code. The other reason why VS Code is not all that useful is because it doesn't know how to syntax highlight HLA code. And I have created this environment so that it knows how to syntax highlight in here. This particular editor does. Okay, so the structure of an HLA program. I'm just going to remind you that you should put the assignment name, your name, and the date at the top. HLA commenting is just like C++. You can use 2 forward slashes for a single line comment, which is the only kind of comment I personally use anywhere in any of my code anymore. But you can also use the multi-line /* commenting in HLA, although you won't see me use it. Okay, so I'm going to go ahead and do that. So instead of assignment name, this is lab 2. In fact, I'm going to be even more specific. Week 2, lab 2. Put my name in there. Put today's date in there. Today is the 31st of August, 2020. That's how I like to write my dates. Oh, okay, you're asking a CSCI, a PNA2 question. That's why. And then just get in the habit. If there's a little star up here, it's not a problem though. If there's a little star up here, you need to save. So just get in the habit of saving on occasion. Here's the syntax highlighting I was talking about. For PNA2, by the way, you can use VS Code and paste into Replit if you're still here. That's how I name. So the question is the assignment name? That's how I would usually name it. The week 2 just reminds me of what module it came from, and then it's the second lab. So that's how I would typically name them. And when I get a full-on project, I would just put the name of the project up there at the top. Yeah. Okay, so you should just get in the habit of doing that because I'll always check for that, and there's always points for that. So here's the basic structure of an HLA program. Program, and then here is the program name, followed by a semicolon. I tend to name mine like this. You can call it kind of like a variable name, the program name, but there could be no spaces. You can use underscores. I just, for some reason, I don't like the way that looks, so I spell out the number, lab 2. So you have a program start, and then you have a begin, lab 2, and then an end, lab 2. So that's what the basic, and I'm going to do a save just as I go along in case something happens. I'm always not far from the last time I click save. And this is a little thing that takes getting used to, but this is how an HLA program is set up. You have a program line, and then you have a begin and an end. Now this section right here, this is like main. So in C++, this would be like int main. Same for in Go, by the way, or whatever language. This is like main. That's where main goes, between begin and end. In between program and begin is where you put your includes, and it's where you declare variables. Now I'm putting these notes here so that you can see them on the stream. I would not probably put this extra commenting in my own code because I know where things go. But so that you can see it if you're watching the video later, and so you can see it on the stream. Between program and begin is all of the extra stuff that you use to make a program. You put your includes in here, you put your variable declarations in here, and then your main. So one thing that you should immediately object to is that that looks like globals, and they are. And doesn't that feel kind of naughty and fun? Yes, basically they are globals, and we get to use them like globals, and that's the way it works in HLA. So I consider that fun because I know it's wrong, and I'm going to do it because that's what HLA wants. Okay, so that's sort of the basic structure. So for includes, in our class, we're always going to have one, and always only ever one, which is standard live.hhf. This has absolutely everything connected to it. This is literally the only include that you ever need in this class because everything else comes from here. All of the output stuff, all of the input stuff, random numbers, all of the arithmetic, everything comes with this one include. So that's pretty nice because we don't need any more than the one include. In fact, I should just say include because there's only ever the one. I'm going to click save just to be a little extra paranoid. Variables. Okay, so how do you declare a variable in HLA? You create a little section marker called static. And then I usually tab over one for this section. And in here you put your variables. So we need two numbers and a character, I think. So I will call this number 1. And then you'll have to get used to the data types, but the instructions tell us to use 8-bit unsigned integers. We just saw an 8-bit number, by the way, in talking about binary numbers. So this is a number that goes from 2 to the 0 up to 2 to the 7th and no further. In HLA, by the way, I know this is a lot, but you'll get the code and you can mull it over. This is zeroed out for you automatically. C++ does not do that. HLA does. So there's the first number. I'll make another number. Notice I'm still in the static section. It's also supposed to be an uns8, so that will be zeroed out by default. And then I'm supposed to put a character to see if they want to continue. You can, yeah. So I think you can use uns64 in this class. So someone asked, can I use a 64-bit unsigned integer? And I believe HLA has it, the version of HLA that's in here. If you get an error, just drop back down to 32-bit. So in our class, we will commonly use 8-bit, 16-bit, and 32-bit integers. But I believe that this version of HLA does actually have 64-bit integers also. This will be a char. Okay, so the integer data types are a little bit different. I'm just sort of giving you these for free for this week, and we'll talk about it more. So there's number 1, which is an uns8, and I know this is not the way you're used to writing variables, but this is the HLA way. Number 2, which is also an unsigned 8. You can use numbers, by the way. I just don't like the way this looks. It's my personal preference, to be honest. So you can name variables like that. I just happen to think this looks more attractive for my coding work. But you can do whatever you like. And then I named a variable called input and made that be a single character. Which if you've done C++, then you'll know the char data type. Okay, so there's my static section and all my variables. Now I'm going to go down and do main. In my HLA code, by the way, I tend to put a fair amount of spacing between things. I know it's 12. I apologize for that. If you can hang around, You can do camel casing in HLA is the question of what's the ruling, the naming rules. They're the same as in C++ or Go or Python. So you can use camel case, you can use snake case, we call this. The main rule that it has is that they cannot start with a digit and they can't have spaces in them. So I happen to like camel case. It's kind of what I was trained on and I'm used to it. But HLA supports all the common naming styles for variables, and you can use any style that you want. I recommend that once you pick a style, stick with it so your code looks good, but you can use any naming style that you like. HLA supports all the common ones. Snake casing, camel casing, those kinds of things. Okay, so I tend to put more blank lines in my HLA code than in other languages, but I'm going to go down to main, and I'm going to fire up a program loop. So this is another thing that we're going to do commonly in HLA that's considered a no-no in other languages. This is an infinite loop, and it's on purpose. But we're going to immediately write the code. Yeah, and I think it's actually clear, isn't it? It uses the word forever, and it means forever unless you do something about it. So what I usually do for my main program loop is I use a forever loop in HLA. And then immediately, I go down and I write the code to handle the problem that this would be an infinite loop if I don't stop it. So, go again. No doubt you've all written a statement like this. I'm going to stretch out my window a bit so I can fit more stuff on it. So anyway, what I'm doing is I went right down to the sort of the bottom end of the forever loop, and I'm immediately going to write the code that would make it not be a forever loop anymore. So there is dynamic memory, which we'll use later in the semester in HLA. It does not have garbage collection. So if you do something on the heap, it will not be garbage collected. But we won't do anything on the heap for many, many weeks now, although you can, and it will not garbage collect it. Okay, it's like C in that respect. Okay, so here's an output statement. Go again. So the reason I'm doing this first is because this will be the way that I get out of my forever loop. I'm going to use standard in.get there input. So HLA has this. We won't use it a whole lot this semester, but they have a handy dandy. If you have a variable like input and you ask HLA to get it, it will sort of match it to the data type for you. So I'm getting input, which is a character, which I expect to be yes or no. And then HLA has this handy dandy feature. Actually, let's do this first. You should do these flushes after all your gets. It's just the safe thing to do. You won't notice this happening, but it will prevent little input weirdnesses later on. So as soon as you do a get, do a flush. And then we will do this handy dandy feature, which is a break if statement. So this break if will break this forever. And the if is if their input is a little y, and let's be careful and say, or if it's a big Y. And you'll notice that Boolean expressions in HLA are the same as in whatever language you're likely to have learned up to this point. There's no built-in way in HLA to force the user to give you the character that you want. You'd have to put that in a separate loop, which I'll do that here for the numbers, and you'll see how that works. But there's no built-in way to use this get and say, oh, and I only want y's and n's. You have to wrap that in another loop to do that. So the reason I wrote this first is because that's what will cause this to not be an actual forever loop. In fact, let's save it and go compile it and try it. So I've clicked over in the terminal. You can output an error. In fact, I'll show you how to do that as among my last couple of things. So the question was, can I output an error if they put in an input I don't want? And the answer is yes, you can. And I'll show you how to do that with the numbers, and then you can, if you want to, use it for the characters. Okay, so to compile, I clicked over in my terminal, HLA space, and then lab2.hla is the new file that I want to compile. I hit enter and cross my fingers that nothing happens. So if nothing happens, then all is good in the world. And then I can do /lab2. If nothing happens when you compile, that means the program was successfully compiled, and the program's name will be the same as your file name except for with no extension. So /lab2. So there immediately my forever loop is knowing and yesing. So if I say, go again, I did it backwards. If I say yes, it's going to break. If I say no, it should keep going because I did the logic backwards. Okay, so it did quit on yes, but that's backwards. So I'm going to go back to the code. That actually was break if they say no, because the question was, do you want to go in again? If they say no, that's when to not go again. So I'll fix that. Okay, so now I'm going to do one sort of semi-elaborate piece. Yeah, if you type anything that's not an N, technically it's going to keep going. Okay, so let's do so now I'm back up at the top of the loop because this is actually what I want the program to do when we get to the loop, which is to ask for a number. So I'm going to say, so you have to put, please enter center. No, I'm not going to say please. Enter a number between 1 and 50. And this will be the first number. Okay, so the program says the assignment says don't let them get out of here unless they give you between 1 and 50. So I'm going to use another kind of loop, and I kind of created this assignment just to give you a chance to experiment with these features of the language. So we're going to wrap this thing in a repeat until loop. This is like a do-while loop. If you've learned a language that has a do-while loop, this is a do-while loop. It's a repeat until. Until the number is greater than or equal to 1 and the number is less than or equal to 50. So as to satisfy both of those, or they're not getting out of here. And what I might do, let's do the error message. So while you're in here, being stuck because you don't know what 1 and 50 mean, let's put a little nastygram in, shall we? So if the number is less than 1 or number 1, I'm not putting number 1 everywhere. Number 1 is less than 1. Let's make these number 1. Because there's no such thing called number. If number 1 is less than 1 or number 1 is greater than 50, then, this is the thing that gets people in this language, then you'll get used to it, you'll get errors, and eventually you will remember to put the then in there. Then, separate this out a little bit because it's getting to be a little bit much to look at. Nope. Okay. So what happens? I will say put invalid input. Why is it wrapping? I guess it ran out of space. Let me stretch this out a little bit so you can see the whole thing. Is that doing it? Yeah. Invalid input. Hold on, there's a whole bunch of whatever. Invalid input. And then this is a new line character, so I'll put a new line in there. And then end if. So this is a lot to take in. You may have to review the video a little bit to get all of this from the sample that I'm doing. That whole loop is just to make sure that I get a number between 1 and 50. I forgot something. I don't know if anyone noticed it. I forgot to do a flush input here. So every time you do a get, do a flush input after it. You'll thank yourself later. So this whole repeat until right here is for the first number only. They're going to get prompted for a number. They're going to type one in. I'm going to do a flush after the get. And then I have an if-then statement. This is how you close them, end if. If you didn't give me a number that I wanted, you're going to get an error message. And then the repeat until will also know that and start over again. So that's how that's for one input, which means you're going to have to repeat that whole thing twice. There are procedures in HLA, but we're not using them yet. Now you're going to have to repeat that again to get the second number. Finally, you get to the point where you can compare the numbers. I'm going to pseudocode this a little bit. So this is where you're going to say, and you're not going to like this, but I'm going to make an error. I'm going to make an error on purpose so that you've seen it, and then I'm going to show you how to fix it. So you're going to want to do this. You're going to want to say, for example, if number 1 is less than number 2, then you're going to want to output number 1, that's the variable value, less than, and notice I'm using commas between each part, so the variable, comma, the string, comma, the other variable, comma, and then a new line character. And then you're going to end up with else if other stuff. And possibly else if other stuff, and possibly an else section, and then finally an end if. Okay, I'm going to comment these out. But that's just there as a breadcrumb for you. That's the rest of the program, basically. But I'm going to get an error, and then I want to show you how to resolve it. So this will be your first taste of kind of an Intel assembly language restriction. So I saved it. I'm going to try to compile it again, and I'm going to get errors. Okay, so this is the error to be on the lookout for. Memory-to-memory comparisons. Now it does tell me that it happened at line 36. Memory-to-memory comparisons. What that means is, when it says memory, it means a variable. Basically a variable that you've created that exists in memory. So line 36 has a variable-to-variable comparison. It is right here. So it turns out that in HLA, to give you a flavor, and then later more of a flavor of the restrictions of the Intel processor, the Intel processor actually can't work with two variables in RAM at the same time. So the fix to this is to put one of them in the processor directly. So I'm going to actually take the first number and I'm going to put it on the processor. So AL is in the processor. We call it a register. It's a memory bank that's not in RAM. It's actually on the processor itself. So I have moved, and by the way, in Intel, move means copy. I've copied the value of that variable onto the processor. Now I'm going to use the value that's in the processor to compare against the value in memory, and now I'm no longer breaking the rule. Going to save and make sure that it compiles. Oh, here's a trick in here, by the way. If you type clear, new screen, so that's nice. HLA lab 2.HLA. Now it compiles. It's incomplete, but it will run. Let's try it. I'm going to be a jerk and put 51. It won't let me. That's invalid. If I put 0, that's invalid. If I put 25, it should let me go. Now the reason I didn't do any output is because I only have an if statement to see if my number is less than number 2, which is currently 0. And then I'll say no, don't go again, program over. So I hope that that is enough to get everyone Is there any more of the program? That's as close as, can I do this? I can't. So that's as much, I think, as I can show you. Yeah, that's as much as I can possibly show you. Okay, so someone has a question. So yeah, actually AMD is the same architecture. So Intel designs and manufactures what they call the x86, and now they have x86-64 family of processors. AMD also manufactures x86 processors. So it turns out that deep down inside they're the same processor. So all of this same stuff works on AMD exactly the same way as it would on Intel, because they're both the same architecture. PowerPC is a different architecture, so that would be different. Macs at present use ARM, but I think that they're about to switch off to some other architecture. So at present, deep down underneath it would be the same. There is also the operating system that changes the way software interacts with the processor. So like your, if you have a phone, like an Android or an iPhone, those are ARM processors, and those are completely different underneath. Okay, that's all I've got. Thanks for sticking around for the extra 15 minutes. I hope that this is useful to you. Yeah, thank you, Captain Price. Appreciate it. I'll post this video. I usually will start all the downloads and uploads and then go eat some lunch. But anyway, the videos will get posted on the videos page and on the lecture page, so look for that to pop up later this afternoon. Thanks, Tyler. So I will see if I have time to do a drop-in Zoom on Wednesday. I'll put an announcement. So please check announcements to see if I do like an open for everybody Zoom. There still are the 15-minute blocks if you want to meet with me one-on-one. But otherwise, expect to see me next Monday. No, not next Monday. That's Labor Day. So next week, I'll do the live broadcast at a different time because I'm not allowed to work to make you guys do stuff on Labor Day. So I'll broadcast it and post about that. Anyway, you will see me next week doing a live broadcast, and I will put announcements about the times that you can come and drop in on me doing live stuff next week very, very soon. So thank you, Atsuya. Everybody have a good week. Please use Piazza. Yeah, that gives your classmates a chance to step in and help you out. But if you need to use the Canvas inbox to drop me a direct communication, don't hesitate to do that either. So everybody take care.